Good morning, I be to the examiners Dr. Abang Muhammad Nizam and Mr. Rasli. My name is Iven ESTRADA Gabriel with a matrix number of 63264. My final year project is entitled The Application of Cableway System for a Pineapple Handling in Highland Area of Kampung Sinulihan, Tuaran, Sabah. I am under the supervision of Dr. Anna Sakura. Today's presentation will be divided into 5 sections, which is the introduction, literature review, methodology, result and discussion, and finally, conclusion and recommendation. First, the introduction. I will discuss further on the background of the study. The study is conducted at Kampung Sinulihan, a village that sits on a mountainous area. The nearest town is Kundasang, that is located approximately 30 kilometers away. Agriculture is the main economic activity, such as pineapple farming. However, due to difficult terrain, construction on road is very limited, cause most farms are not accessible by any vehicles. Therefore, conventionally, they use wakit, a traditional rattan basket, to transport their product from the farm. This cableway system project is conducted to solve the problem faced by the community. First, with conventional method of transporting, longer time taken to transport the pineapple from the farm due to limited capacity of the wakit. This arises another problem, which is accident risk due to the workers have to go back and forth to complete the transporting process. Realizing this, the farmer decided to reduce the numbers of pineapple harvested every season. Thus, the farm doesn't operate at its maximum capacity. The objectives of this project is, first, to determine the parameters that affect the performance of cableway system. Second, to develop a practical and economical cableway system. And lastly, to develop a cableway system. Next, I will talk about the literature review. I have done some benchmarking on projects that related to the cableway system. A benchmarking conducted on several projects done by previous researchers. First, a portable cableway system in India constructed with a budget of 4,000 US dollar due to the shortage of workers. Second, a low-cost cableway system powered by gravitational force has a capacity of transporting 300 kg of goods per hour. This hilly application requires more than 16,000 ringgit. Another benchmarking done on a palm oil bunch transportation conducted by the MPOB, which can carry up to 500 kg per trip. Next, methodology. I will discuss further on the backbone of the whole project. This is the overall design system for the cableway system. The cableway system consists of several components, that is wheel, steering, pulley, track and whole cable, hook and pole. This system has a two cable, which is the track cable and whole cable. The track cable acts as a guide for the hook. The hook is controlled by the wheel via a whole cable. To smoothen the reeling process, a pulley is added. A ratchet gear is added to allow the hook move in a single direction. On every immediate pole, 4 U-groove bearing installed in a series to smoothen the hook movement. For the geographical information, the Google Maps is being fully utilized. From that, the elevation difference between the farm and the access road is known to be 70 meters with aerial distance of 125 meters. From this, the slope of the hill is about 29 degrees with an approximately 143 meters of slanted distance. Then, a critical component being analyzed. First, the main cable. The system is conducted to estimate the highest tension of the cable during operation. From the FBD, we are able to identify the highest tension is 4.3 kN. From this information, it is necessary to choose a ropeway cable that has higher tensile strength than this value. Another critical component is the pole. To ease the calculation, the pole is divided into two sections and analyzed accordingly. We assume the load of pineapple is 600 Newton, which is equivalent to 40 pineapples with a mass of 60 kg. We want to identify the contour weight required to balance the load. In this case, it is the T1, which is the tension required by the stair wire to ensure the pole remain upright. Based on the calculation, we found out that the required tension is 731 kN. Therefore, the selection of the cable must refer to this requirement. The pineapple farm sits on a mountainous area with a low soil and strong wind. Therefore, a footing must be constructed. According to Murthy, the design of the footing is acceptable if the safety factor is more than 1.5. From the analysis, we found out that the footing to be constructed, which is 0.5 meter deep with 0.2 meter square, has a safety factor of 2.15, which is acceptable. Once the design and component finalized, the installation can be begun. First, the pole will be installed. The pole will be strengthened by the footing. A stair wire will be added with additional of cable tensioner. This cable will be tensioned once the main cable installed. Next is the main or track cable installation. To adjust the tension later, both ends will be occupied with the cable tensioner and fixed with a metal clamp as shown in this figure. The last step will be installation of others component. It began with the wheel installed onto a design mounting via a shaft. One end of the shaft, a steering wheel is installed and locked with a pin. A ratchet gear also inserted into the shaft and the pole on the mounting. Next, the pulley hangs on the design mounting that is located below the track cable and placed in parallel to ensure the whole cable align accordingly. Next, the hook rests on the main cable. Then a whole cable is then tied to it as it passes the pulley. Another end of the whole cable is reeled on the wheel. Now, I will present on the result from a test that conducted to prove the functionality of the system. Next, design justification. As we know, there are many types of cableway system. For this project, a bi-cable system is chosen. This selection altered by the nature of the system setup that is very simple. It requires basic equipment to be set up, such as only a hand tools. This is because the proposed location has a very limited access and difficult to bring many equipment to be used. Another advantage for the system is that it requires less maintenance to be conducted due to less moving component. With advancement in today's world, automation has become the choice for most industry players. However, for this cableway system, manual operation is chosen. This is because it is specifically designed for an off-grid farm with no electric facility nearby. This system will rely on a gravitational force to bring down the pineapple from the farm. For the pole, I use a circular hollow tube. With a strong wind, this is a high chance that any structure to topple. According to Wardier, circular tube has a lower drag force, hence it can withstand a strong wind. Next is the selection of cable. There are two different cables, which is the track cable and haul cable. For the track cable, we are looking for an affordable and reliable cable. From the trees analysis, a 12 mm nylon cable is more realistic with a lower cost. It able to hold the pineapple during transportation. It also has a higher tensile strength compared to the tension of the cable which experienced during the operation. Next, for the whole cable, flexibility and strength is needed. 6 mm nylon rope is suitable due to its flexibility to be reeled by the wheel. The descending test is resembled in actual application of the pineapple transporting process, which is from the farm uphill to the access road downhill. For the test, the distance is set to be 20 meter only, with equivalent mass from 3 kg to 40 kg, with an increment of 2 kg. From the graph, we can see that the velocity is very inconsistent, but when a base fit line generated, the velocity shows slight increases. The average velocity for the system is 0.2691 meter per second. Next, the ascending test. This test also uses the same setting as the descending test. This is a combined graph of velocity and time taken against the mass of pineapple. From the graph, the velocity is inversely proportional to the mass of pineapple. The time taken, however, is proportional to the mass of pineapple. In actual application, ascending test might not be as important as the descending test. However, in case of farmer desire to bring any agriculture equipment from the access road to the farm, this data also very significant. From the graph, we identify that 8.5 kg is the most optimum mass to be carried. However, for convenience, the optimum mass marked green with its range from 7 kg to 10 kg. Next, validation. We want to see the impact of installation of a Cableway system on the pineapple farm. In time perspective, the Cableway system has cut the time by 50% from 30 minutes to 15 minutes. The Cableway system also increased the capacity of load by 200% from 35 kg per trip to 60 kg per trip. The most important is the risk assessment. Before this, the workers exposed to accident due to harsh terrain and heavy load, which done continuously. With the Cableway system, the risk can be eliminated. During the test, the only accident occur is when the hook slips from the main track due to uncontrolled velocity. Hence, it is important for the operator to remain alert while operating this system. Finally, the conclusion. We will summarize the achievement based on the objective set earlier. The first objective is to determine the related parameter that enhance the performance of Cableway system. This objective is successfully achieved. I'm able to gather information whether primary through site visit or interview, such as the pineapple farm background, or secondary data from Google Maps and past research. Next, the next objective is to develop practical and economic Cableway system. We're able to design a functional system that is affordable for the farmers and carry out some critical analysis on the Cableway system. Last, we want to validate the developed Cableway system. The Cableway system able to function properly as expected. The system able to reduce the burden of the farmer at Kampung Sinulihan, Sabah. However, there is no perfect system at first glance. I see there is still some room for improvement. First, the system can be installed with a gearing system. This will much help with the ascending application. Next, the size of the pole can still be reduced as long as it still can oppose the load. This will greatly reduce the cost. And lastly, in terms of design, the distance between the pole to the U-groove bearing in immediate pole have to be slightly increases. This will help to reduce the possibility of the load to hit the pole during transportation. That's all from me. Thank you.